Alright, this is Math 2, looking at your semester review. We're going to start off with Unit 8. And I have several of these so they're broken up in smaller chunks so you can review them one at a time. So here we go. As we start the Unit 8 semester review, just a few things to keep in mind. I'm going to put this up here real quick. I'm going to show you that there are several elements you want to kind of start to memorize and make sure you know. So if you want to make your own little note card or cheat sheet, there's some basic things you want to be able to know when you get to the test. So remember basic Pythagorean theorem, a squared plus b squared equals c squared. When you have triangles, how do you find the missing length of a triangle? That comes up in this unit a little bit there. You do have to remember some things from basic geometry. Supplementary angles are when you have a straight line and you add the two angles together to add up to 180 degrees. Recall that inside of a triangle, you have a total of a sum of 180 degrees inside of a triangle. You'll be talking about things like a tangent line, which means it's next to the circle, not going through it, but right next to it. You have to recall that a radius is half the line from the center point of the circle to the outer edge, whereas the diameter is the full length going across the midpoint of the circle. There are also things we'll talk about like central angles. A central angle is an angle that is going around the midpoint of the circle. This one here happens to be a little smaller. You could have a central angle that works like this, where it's larger, and that's okay. It's still called a central angle. Some of our things we want to keep in mind for finding arc length and things of that nature is when you have an angle, a central angle on the inside, the arc directly across from it is that same measurement. So if this is 85 degrees, this would also be 85 degrees. When you're looking at the interior angle that's not the central, if this is 35, the arc across from that is twice that length. So 35 times 2 is 70. Or if they give you this length and you want to go back in that direction, it's half of that. So it depends on which way you want to go. It's either double or it's half. When it's central, it's the same. When it's the one across, then it's going to be half of that or double, depending on which direction you're going. The formula for an arc length is here with the degree they give you, whatever that angle might be in degree, divided by 360 times 2 pi r. All that this means is, and think about this, is if I'm looking for the arc length, I'm talking about a circle now, and I take the degree, and it's what part of the circle times the formula for the circumference, the distance around the circle. So basically, I could find out the circumference, 2 pi r, and I multiply that by whatever part of the circle I'm dealing with for the arc length. The same idea is true for the area of a sector. This is our area formula for a circle, pi r squared, but I don't want to know the whole circle, I just want to know part of it. So I use this, the end, whatever the degree is going to be here, divided by 360, to get that section times pi r squared. So it's basically what part of the circle times the area of the whole circle. Alright, so we're going to use that to help us here. And let's start with number 1. Number 1, we have a triangle, and we have basically an a squared plus a b squared and a c squared here. And so I can set this up as a squared plus b squared equals c squared. And they didn't give me the a, so I'll leave the a squared there. And my b squared in this case is 20 squared. And that's going to equal my c squared, which is 25 squared. Okay, I probably should have left these as ABCs. Sorry about that. ABCs. So, to move on here, a squared is going to plus 20 squared is 400, and 25 squared is 625. I will subtract 400 from both sides to find out that a squared by itself is equal to 225. To find out what that is, I take the square root of both sides, and the square root of 225 is 15. So the missing measurement for this part of the triangle is going to be 15. Okay? So that's what I do there for finding the value of QR, 15. Number 2, what I have here is it wants me to find WTP. Recall we talked about before is that if this angle is 130, then that arc length is also 130. And if that's the case, the inscribed angle over here is equal to, in this direction, is equal to half of that. So I take 130 and I divide it by 2 to find out half the angle. What I have, the measurement here is half the angle measurement. So 130 divided by 2 is 75 degrees for number 2. Oh, sorry, 65. That's what I'm thinking today. It's too early. Sorry about that. It's 5 o'clock in the morning. What do you know? So 65 degrees for number 2. Sorry about that. Let's move down to number 3. Number 3. When you look at these problems, there's different ways to approach them, and so I'm going to show you how what I saw first. It's geometry, so you might see something different first and work from there. But let me just show you what I did. I looked here and saw that I had to find BKG, so I have to find out the measurement of this angle right here. That's what I'm trying to discover, right there. So what I did is I said, well, I could figure out arc lengths and things like that. That's what this lesson's about. So let's take a look here. I have a supplementary angle right there. Okay, I was given 84. So if I did 180 minus 84, that leaves me with 96 degrees for the measurement of that spot right there. That angle is 96 degrees. Because we're talking about arc length, that's a central angle, that means the measurement of that arc is also 96 degrees. This happens to be an inscribed angle containing the BG arc here of 96 degrees, which means that that angle measurement is going to be equal to half. So if I take the 96 degrees and divide it by 2, I end up with 48 degrees, and that is the measurement of angle BKG equals 48 degrees. Does that make sense? So we took what we had here, found a supplementary, 180 minus 84, found what was missing, looked across, determined what that arc was, and then divided that in half for the inscribed angle over there for 48 degrees. Number 4, they give us an inscribed angle to start with. That's nice. I want to find out the value of x here. So they also told me that this length right there is 56. So to go across, I can take the 32, and because it's inscribed, the arc is going to be twice that. So I multiply by 2, and I have 64. So this measurement is 64. That's 156. An entire circle is going to be 360. So what I want to do is take my 156 that I was given, add to it the 64 we just found, and we have 220, and that's what this entire length is going to be. This whole length is 220, and what's left is 360 minus 220 for 140 degrees. So x equals 140 degrees because that's what remains. Okay, number 5. 5 is a bit more complicated because there's more things happening and it takes multiple steps to get there. And again, there's different ways of approaching this, so here we go. What I did first is I'm looking at inscribed angles. What do I know? If this is 28 degrees here, I'm going to zoom in here because it's a little small. If this is 28 degrees, I know that the arc measurement across is twice that. So 28 times 2 is 56. So if that's 56 degrees, then that tells me that the angle measurement right here, DOL, is also 56 degrees. Okay? That's good to know, okay, because I will need that in a little bit here. One of the things it's asking me to do is to find ODL. I have to find out this measurement there. I'm also asked to find out MDL, so the whole thing there. And I'm also supposed to find out M to D. Okay? It's a lot to figure out. But I'm going to not go in that order necessarily because this is a diameter, which means that from here all the way to here, I have 180 degrees. I've already determined that that's 56. So my next step would be to do 180 minus 56, subtracting there, and we get 124 degrees for arc measure 124. That means, though, that this is an central interior angle. That means that the measurement of this angle right here is 124. Now I could have also solved that by recognizing this is supplementary, and I could have done 180 minus 56 here to go that direction. Doesn't matter. Then you have to see that, oh, central angle, that makes that 124. So now I have that being 124. I can now find out what this angle measurement is going to be, because this is going to be the sum of two angles divided by 180 minus those two. So I have a 124, I have a 28, which adds up to a 152. A triangle, sum of the angle of a triangle is 180, so I'll do 180 minus 152, and that's going to give me 8 and 2, 28 degrees for the measurement of angle, and this is MDO, or MDO. Did I need that one? Sorry about that. I need ODL and the whole thing. Okay, I do need that. I need that in a second. So I'm going to hang on to this one here. This becomes 28. Sorry. 28 right there. Okay, from that space, 28. And I'm going to use that in a second here. So this is 56, 28. I'm getting all these sums here. I have my 124. I want to find out what L is real quick. And to go back to inscribe, that's going to be half. So the measurement of angle L is going to be half of 124. So 124 divided by 2 equals 62 degrees. Alright, so this is 62. So I have a triangle there. That triangle, I have a 56, a 62, and I have to find out that space. So I do 62 plus 56 is 8, 118. Alright, 118. And what's left right there from 118 is 180 minus 118. We have 7, we have 2, and 7 minus 1 is 6, 62. So this missing angle is 62. We knew that other one on the side over here, this way, was a 28. So let's put this all back together. So lots of little math things here to figure this out. Okay, we're supposed to find out, I'm going to zoom out here a little bit here. These three things. The measurement of ODL. ODL was here, and that's what we did in this space right here. We found out the 56, we did half of the arc angle, and we subtracted both the sum there from 180 to find out that this angle, ODL, was equal to 62 degrees. Then, for the measurement of MDL, that is going to be the sum of the 28 and the 62, which total up to 90 degrees. So that came from finding out that measurement, central angle, plus the 28, adding those together, and then subtracting it from the 180 to get the 28 number. So that's where my 28 came from. Here's my 28, and here's my 62. So 62 came from there, 28 came from there, to get a total of 90 for the whole thing. And the arc measurement of MD, we already discovered, was from here, 124 degrees. Okay? It's a little complicated. This one takes a little more time, but that's all putting all the pieces together for how you solve that there. Okay, moving down here, number 6. It says the measure, we're trying to decide always true, sometimes never, and give some examples. The measure of a central angle equals half the intercepted arc. That is going to be a never true, because with our central angle, the central angle, if this is x, the intercepted arc equals that. The one that's half is the one that goes in here, the inscribed. The inscribed is half, not the central. Circles are congruent. That's going to be sometimes true, because sometimes you could have a little circle, and sometimes you could have a big circle. Remember, congruent is a nice way of saying pretty much they're equal, they're exactly the same, they match. Those don't match, but they are indeed, on the next question, similar. Circles are always similar, that's what makes them circles. And for number F here, letter F, it says two diameters divide a circle into 4 congruent arcs, each with a measure of 90 degrees. Now, I could do that. I could take a circle, and I could have a diameter, and say, oh, perfect, 90 degrees, and they're all equal, 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 equal. Isn't that cute? But I could also take my diameter and I could draw one here, and I could draw another diameter here. Well, that's congruent to that, but those are not congruent, nor are they 90 degrees. So this would be an example of not always true, but sometimes true. I can make it work here, but in this case, it's not going to be true. So that's why that is a sometimes true, and that's how it works. Okay, let's go to the next page. So this next page, I know it says Unit 9, but I want to make sure I keep it with your notes, because your notes are actually going to go in Unit 8 all the way down to here. So I'm going to go all the way down to number 2A, even though this says Unit 9 on it. I'm going to write Unit 9 right here. We'll come back to that in our second video, and this is going to still be a continuation of Unit 8 right here. Okay, the formula used to find an arc length. You need to just memorize these things, okay? The formula for the arc length, again, it's going to be the arc we're looking at, that degree, so what fraction of the circle times our circumference formula, 2 pi r, or 2 times the radius. If you want to just use diameter pi, that's fine too. I always just use radius, okay? So when I get to number 8, it says to compute the arc length of AB, our formula is to look at the angle. This angle is a 90 degree angle. So I'd set it up by saying 90 over 360 times 2 times pi times the radius, which is 16. So that's my setup. So 90 divided by 360 times 2 times pi times 16. And that all is going to equal out to 8 pi. Okay? I'm going to let you do the math on that, but you can use your calculator. You could simplify, get rid of the zeros, and move on. All right. The next one for B, we have to work a little bit backwards here. It says the length arc of AB is 4 pi. So we're leaving in terms of pi. So I know that this length is 4 pi. Find the radius. So what I recommend is this. We know our formula. Our formula is 45, the angle, over 360 times 2 pi, and we're looking for the radius, so I leave it there. I'm going to make it equal to the solution, which is 4 pi. Okay, so that's my formula for the arc length, and I'm setting it equal to what the arc length actually is. And by doing this, I have pi's on both sides, so I can actually just cancel the 2 pi's out. No problem there. Okay, I could take this 2 and I can divide both sides by 2. If I divide by 2, I now have 45 over 360 r equals 2. And then 45 over 360, the division on that is going to be, this becomes a, turn this on, 45 divided by 360 equals 0.125. So now if I take my 2 and I divide it by 0.125, I end up with 16. So r equals 16. I'm going to divide the 0.125 on both sides. Okay, now that's my radius. So my radius is 16. But if I look over to the side here, it wants to know both radius and diameter. So radius is 16, which makes the diameter twice that, 32. Do be careful about these questions that you're finding out what it wants. It wants the radius here, not just the diameter, or whatever it might be. So make sure you're reading the directions to know what it's looking for. You always have a distractor, typically you have a distractor where it's going to say, well, here's the radius solution answer, but just look what it's asking for. Okay, formula to use the area of a sector. That's going to again be the arc divided by 360 times the area, formula for the area of a circle. So we're looking for what part of the circle makes up that area, okay, for the formula for the area of a circle. This one here, again, just be careful to look at what they're measuring here. It tells you compute the area of sector DOE. All right, now just be careful of your eyeballs. It says this, with a central angle of 210. That means we're looking at this portion right there, okay? The central angle of 210. So don't do the smaller part. This one wants to know the big part, so pay attention to the directions there. So in this case, what we would do is we would use our formula, and we would say, well, we have 210 over 360 times pi times the radius, which is 2 squared. And that's going to be our solution when we work that out there. So 210 over 360, I can continue to reduce that until I get down to a nice small number, right? So I could cross out the zeros. I have 21 over 36. 3 goes into there 7 times. 3 goes into there 12 times. Okay, I have a pi still, and 2 squared is 4. Alright, so now I can do 4 times 2, which is 28. So I have 28 over 12 pi, and now it's a matter of just continuing to reduce. 28 and 12 are both even numbers, so I can reduce that to 14, cut them in half. Right, no, yeah. 14 and 6 pi. Those are still even numbers, so I can reduce it again, and I can have 7 over 3 pi. So I can continue to reduce. Just make sure you continue to reduce down to the simplest terms there. And that ends up being choice C. And they write it as 7 pi over 3. I wrote it 7/3 pi. It really doesn't matter, but we do have feet squared for the area there. Okay, so that's a review again of the Unit 8. And again, these were the kind of little notes that I had to start off with. Something you might want to just make sure you're familiar with these things as you get ready. Oh, I can't go any further out. As you get ready to study for Unit 8. Alright, so I hope that helps a little bit with a review for Unit 8 and get you ready for your semester final. Good luck on that part.